Namaskar. I welcome you all in this class of mathematics. So, friends, last time we discussed permutation. We are discussing the chapter that is the techniques of counting. It is quite interesting chapter. So, in permutation we learnt that if order is important, suppose we have to select n things, we have to select r things out of n things in which order is important. So, we use notation NPR and its formula is factorial n divided by factorial n minus r. Today, we are going to study and discuss combination. Last time we discussed permutation and this time we are going to discuss combination. What is the difference? In combination, order does not matter, order is not important. So, if we have to select or choose say R groups or combination out of n distinct things So, in how many ways this can be done? We denote it NCR. C stands for combination, or we can write C n comma R, or also this notation is also followed. So, the formula for NCR is factorial n divided by factorial r into factorial n minus r. Now, we have to understand that last time we studied permutation. Say there are r positions to be filled out of n distinct things here. If the order is important, say you have to make letter out of 26, 5 letters can be A, B, C, D, E, and if I change the order B, A, C, D, E. It will be a different letter word. Again C, A, B, D, E. So, out of these 5 letters only, different permutations are possible, but this is permutation. Where order is important. Suppose order is not important, combination is to be done. So, this becomes, say, permutation. You see 5 P, let us say take 5 at a time, it will be equal to factorial 5 divided by factorial 5 into factorial 5 minus 5, isn't it? This was NPR, the formula was factorial n divided by, so this is for combination. The formula for permutation is factorial n minus r. So, 5 P 5 will be equal to factorial 5 divided by factorial 5 minus 5 is equal to, this will be factorial 0. So, factorial 5 divided by factorial 0. So, it will be equal to 5 into 4 into 3 into 2 into 1. So, this will be 23 to 60, 120, such a large number. If I take 5 C 5 combination or grouping of 5 things, taking 5 at a time, so it will be equal to, the formula is factorial n divided by factorial 5. First, let me write the formula. NCR factorial r into factorial n minus r. So, 5 C 5 will be equal to factorial 5 upon factorial 5 into factorial 5 minus 5 is equal to, factorial 5 will be cancelled out, 1 will be here and 5 is factorial 0, 1 divided by factorial 0, factorial 0 is 1. So, this will become 1. So, only one combination we can form. So, can you see the difference? If order is important, then 120 ways are possible. If order is not important, then only one way, 5 things can be chosen from out of 5 things. Let us take few examples. say let us take very simple example. 3 letters are there. Three letters are there, A, B, C. Let us take one out of these three, say 3C1. So, it will be equal to factorial 3 divided by factorial 1 into factorial 3 minus 1 is equal to factorial 3 divided by factorial 2, which will be equal to 3. Now, what will be these letters? A, B, C. You can choose either A or B or C, because you have to choose one letter out of these 3 letters. So, there are 3 ways you can choose these letters. 3P1 will be also the same thing, because in one letter order is not important. You have to put A just like that, B just like that, C just like that. So, 3P1 will also be equal to factorial 3 divided by factorial 3 minus 1 is equal to factorial 2. So, factorial 3 divided by factorial 2. So, this will be also equal to 3. Now, we have to take, suppose, 2 letters at a time, 3C2. So, this will be equal to factorial 3 divided by factorial 2 into factorial 3 minus 2. So, this will be 3 into factorial 2 divided by factorial 2 into factorial 1. So, these will be cancelled out. So, it will become 3. So, what are these combinations? AB, BC and AC. Because order is not important here, so BA will not come here. A, B and BA will be one and the same thing, because it is grouping, only grouping is important. The other group is B and C, the third group is A and C. But in case of permutation, you see it will be 3P2. So, factorial 3 divided by factorial 3 minus 2. So, it will be 3 into 2 is equal to 6. So, what are these combinations? A, B, because order is important here. So, B, A is also an option, then B, C and C, B, then A, C and C, A. So, you can see 1, 2, 3, 4, 5, 6. 6 permutation are possible out of these 3 letters taken 2 at a time. And suppose, what is the combination of letters taken 3 at a time? So, it will be equal to 3C3. So, this will be factorial 3 divided by factorial 3 into factorial 3 minus 3. So, this will become factorial 3 divided by factorial 3 into factorial 0. These will be cancelled out, here 1 will be there, factorial 1 is also. So, only one combination is possible, and that combination is A, B, C, because order is not important here. So, only 3 combinations are possible. Now, in the case of permutation, you can see the difference. It will be equal to 3p3, which is equal to factorial 3 divided by factorial 3 minus 3 is equal to factorial 0 is equal to 1. So, it will be equal to 3 into 2 is equal to 6. So, 6 permutations are possible taken 3 letters at a time. And what are these 6 letters? It is A, B, C, then A, C, B, then B, A, C, then B, C, A, and then C, A, B, and C, B, A. So, friends, you can see here that there are 6 permutations possible. Out of these 3 letters taken 3 at a time, because order is important here. A is coming first, and here B is coming next, and C last. The other one is A, C first, and then B. So, these all 6 are distinct and different permutations, but there are 6 possibilities. But in the case of combination, since order is not important here, we have to form group. So, only one group can be made out of these 3 letters, taking 3 at a time. Let us take one more interesting example. Let us take example of ICC World Cup 2023. It is going to be played in October and November. I think it is 5th October to 19th November. So, 10 teams are there, namely if you go alphabetically, Afghanistan, then Australia, Bangladesh, Bharat, England, Netherlands, New Zealand, Pakistan, South Africa and Sri Lanka. So, first the league matches will be played. League means that these 10 teams are there. So, each one has to play with each. So, out of these T10 teams, how many league matches will be there? Out of 10, combination of 2 teams is to be made. So, it is 10C2. So, it will be equal to factorial 10 divided by factorial 2 into factorial 10 minus 2. Here you see that order is not important. If suppose Australia and Afghanistan are 2 teams to be selected. So, you take Afghanistan first and Australia second, or Australia first and Afghanistan second. These 2 teams have to play the match. So, here combination is important, their order is not important. So, how many matches will be there? It will be equal to factorial 10 divided by factorial 2 into factorial 8. So, this will be equal to 10 into 9, and then we can write factorial 8 here, factorial 2 by factorial 8. So, this factorial 8 will be cancelled out, and this will be equal to 90 divided by 2, which is equal to 45. So, there are 45 league matches to be played, but total number of matches are 45 league matches plus 2 semi-finals plus 1 final. So, there are 48 matches to be played. So, friends, it is clear to you that permutation is done when order is important. If R things are to be selected out of n distinct things, then if order is important, we use permutation, and if order is not important, only grouping is to be done, then combination is done, and we have already seen the formula for combination. Let us take few examples to be proved. So, that is NCR is equal to NC n minus R. So, either you combine r distinct things out of n distinct things, or you combine n minus r distinct things out of n distinct things, the number of ways will be same. Let us see. So, let us start from RHS, right hand side. So, n C n minus r, according to formula it will be equal to factorial n divided by factorial n minus r multiplied by factorial n minus r. So, this will be equal to factorial n divided by factorial n minus r into factorial, let us open the bracket. So, it will be factorial n minus n plus r, minus minus plus. So, n will be cancelled out and this will become factorial n divided by factorial n minus r into factorial r, and this is equal to NCR, that is LHS. So, you see NCR will be equal to NC n minus r. Let us take another NCR plus NCR minus 1. NCR plus NC R minus 1 is equal to N plus 1 CR. We have to prove this. So, let us expand according to formula. It will be equal to factorial n divided by factorial r into factorial n minus r plus it will be equal to factorial n upon factorial r minus 1 into factorial n minus r minus 1. So, this will be equal to factorial n upon, in place of factorial r, I will write r into factorial r minus 1, because here factorial r minus 1 is here. So, I want to take common out of this. So, I will write it this like this, and this n minus r as it is factorial n minus r plus this will be equal to factorial n divided by factorial r minus 1 into, it will be factorial n, and if I open the bracket, n minus r and the minus minus plus 1. So, n plus 1 minus r, this will be. So, I can write it n plus 1 minus r multiplied by factorial n minus r. You see, this is the property of factorial, because this factorial n plus 1 minus r will be equal to n plus 1 minus r multiplied by n minus r multiplied by n minus r minus 1. So, it will go so on. So, I can write it as factorial n minus r. Now, I will take common, factorial n is common here in both the terms, and factorial r minus 1 is common. So, let us take factorial r minus 1 multiplied by factorial n minus r, because this is also common. Here also factorial n minus r is there, here also it is there. So, this will become 1 by r, because r will remain here. So, 1 by r plus 1 by n plus 1 minus r. This is the term remaining. So, I have put it here. So, this is simple calculation. R minus 1 factorial n minus r, and here it will become r into n plus 1 minus r, and here it will be n plus 1 minus r plus r. This r and this r will be cancelled. So, it will be equal to n plus 1 into factorial n divided by this r multiplied by factorial r minus 1, it will become factorial r, and here n factorial n minus 1 n minus r is there, and here n plus 1 minus r is here. So, this will become factorial n plus 1 minus r. And this will be equal to factorial n plus 1, because n plus 1 multiplied by factorial n, it will become factorial n plus 1 divided by factorial r into factorial n plus 1 minus r. So, friends, now you can see that this expansion is nothing but the term n plus 1 C r, because if we expand this, factorial n plus 1 is come in the denominator, and in the denominator factorial r into factorial n plus 1 minus r. So, that is what we had to prove. let us take few more examples. Say the question is that from a squad of say 21 players, so 11 batsmen are there, in this. From these 21 players, there are 11 batsmen, 7 say bowlers are there, and 3 wicket keepers are there. We have to select 11 players six, 4, 1. 6 batsmen, 4 bowlers and 1 wicket keeper. So, this is the combination we have to select. How will we do it? So, out of 11 players, 6 batsmen you can make combination 11C6. Okay. Then since 11 batsmen are there, you have to select 6 batsmen. So, out of these 11, you can choose 6 batsmen in 11C6 ways. So, this is combination because order is not important. You are choosing 6 batsmen, first, second, third is not important. Out of 11 batsmen, you have chosen 6. So, there can be 11C6 ways. Now, simultaneously, out of 7 bowlers, 4 is to be selected. So, this will be equal to 7C4. So, fundamental principle of multiplication will be applied here, because these are to be selected simultaneously. So, and this is going to happen. So, multiplication will be there, and simultaneously we have to select 1 wicket keeper out of 3. So, this will be equal to 3C1. So, this is our team, 6 batsmen, 4 bowlers and 1 wicket keeper, 11 players out of these 18 players. 21 players, sorry, 21 players. We have selected the team of 11 players in so many ways. Now, let us take one more example, interesting. Say in a playing card game, there are 52 cards, you know, and 4 suits are there, and in each suit 13 cards are there. Now, the question is that we have to select 3 cards of different suit. So, first you have to choose the 3 suits out of 4, because there are 4 suits. So, you can select 3 out of these 4 suits in 4C3 ways, and then out of these 3, in one suit there will be 13 cards. So, from 13 cards you have to choose one. So, you can choose any one. The number of ways will be 13C1, and from the fundamental principle of multiplication, there will be multiplication here, because these both conditions should satisfy. And similarly, another card you have to choose from another selected suits. You have chosen 3 suits out of 4 in 4C3 ways. So, from one suit, one card you have selected in 13C1 ways. Now, another card from another chosen suit will be equal to again 4C1, and similarly the third card you have to choose from the third chosen suit, that is 13C1. So, these many ways you can select 3 cards of different suits out of a pack of 52 cards. Okay. Suppose another question is there, that you have to select 3 cards of same suits. 3 cards of same suit. So, there are 4 suits. Okay. So, you can take any one suit, and from that you can select 3 cards out of their 13 cards of same suit. So, this can be done in 13C3 ways. Either you can do this, or you could have taken another suit and chosen again 3 cards from that in 13C3 ways. I have used plus sign here, not multiplication, because here fundamental principle of addition will prevail, because either you can choose from this suit or this suit, or any one you can choose. So, it is not simultaneously. You do not have to choose from this and this and this and this. You have to choose any one. So, plus sign will be there. Again, you could have chosen from the third one in 13C3 ways, and you could have chosen from fourth one in 13C3 ways. So, this will be answer, that you can choose 3 cards of same SOET in so many number of ways. Now, in the same problem, let us choose 3 cards of say 3 face cards. So, you know, in the pack of 52 cards, there are 12 face cards in total. 12 face cards. So, out of these 12, you have to choose 3. So, this combination can be done in 12C3. And again, here order is not important. So, the answer will be 12C3. Now, in the same problem, let us say the question is that you have to choose 3 cards. It should be either black or red. So, friends, out of these 52 cards, there are 2 colors. 26 cards are of black color and 26 cards are of red colors. So, you have to choose 3 cards. It should be either black or red. So, suppose you take black. So, 26 out of 26, you can choose 3 cards in 26C3 ways, or you could have either chosen red. So, you can choose red also in 26C3 ways. But since either you can do this or this, so here fundamental principle of addition will be applied. So, it will be equal to 16C3 plus 26C3 plus 26C3. So, this will be equal to 2 into 26C3. Now, let us see problems related to inclusion or exclusion. Sometimes the problem is asked that out of n things, you have to select out of n distinct things, you have to select r n distinct things you have to select r things taken at a time, and there are s things, say it is greater than 0, but less than r. So, this should be always included. So, suppose order is important. So, let us first see what will happen if permutation is to be order is important. So, we have to select r things out of these n things. So, what will be the number of permutation? So, since s things are to be necessarily selected, so we will select first these s things, and there are r total number of things selected. So, r positions are there. In r places we can put s things in how many number of ways, that is RPS. Say these are R places, and out of S we have to fill up this S places from R things. We have to fill up these S places from these R things. So, in how many ways it can be done? It can be done in RPS, that is out of R you can choose S things in RPS ways. Now, the remaining positions, now out of n minus S things are remaining, and from there you have to choose R minus S things. So, this will be the formula. So, yes, 2 minutes are there. Yeah, I am doing it. So, this is the formula when S things we have to include necessarily. This is how we can do it. Next time, friends, we will see that how the combination, this was permutation because order was important here. Now, we will see that if the same condition of inclusion is included, how we can do for combination if the order is not important, and again if exclusion is done, that something is to be excluded, then we will see that how it can be done in how many number of ways. Thank you very much.